So hello, everyone. My name is Alex Velasquez, and I'll be helping facilitate today's webinar. The title is Cisco Intersight Service for HashiCorp Terraform. During this session, we will explore the Cisco Intersight and HashiCorp Terraform Cloud business solutions, including the use cases that each solution addresses. And we will then move on to the Cisco Intersight Service for HashiCorp Terraform joint solution that has recently been announced. Feel free, please, to type your questions during the entire event. There's a Q&A feature that you can easily identify. The webinar will be recorded, and the recording will be made available after processing. I usually take a couple of days to processing, maybe, well, 2 to 3 days. So, and I'll send the link after. Our next slide, we can see today's agenda. So as you can see on the agenda, we were going to be talking about Terraform open source, Terraform Cloud, and we will then, of course, discuss Cisco Intersight Service for HashiCorp Terraform. And the idea is to focus on a strong Q&A session. So again, send your questions. And now I have the pleasure to introduce our speakers, Kyle Roddy and Vinny Ramirez, and I'll ask them to tell us more about themselves. Kyle, will you introduce yourself, please?
Yes, absolutely. Hello, everyone. My name is Kyle Ruddy. I am part of the technical marketing team here at HashiCorp, where I get to focus on all things Terraform, including our really exciting integration here with Cisco Intersight. Vinny?
Yeah, thanks, Kyle. My name is Vinny Ramirez, and I am a cloud solutions architect at HashiCorp, and I have been working directly with Cisco on bringing this partnership to market, and happy to be here presenting to cover what this means, what it looks like technically, and answer some questions today. So thank you, everybody, for attending. All right, that being said, let's jump right into it. So first off, you're here because either you're a Cisco customer of some sort, or you're a Terraform user of some sort, and or interested in why the two words are being used in the same sentence today. So just want to introduce Terraform and make no assumptions that people already know the solution and or use it. So bear with me if you are familiar with Terraform, it'll be a good review for you. So when we talk about Terraform, really where it sits is in this space of provisioning across a wide ecosystem of different technology platforms and solutions. All technology solutions have their own native provisioning or configuration tooling, whether that's a GUI or an API that gets exposed, or their own infrastructure as code solution like we see in the major public clouds. So what Terraform does is it actually standardizes this motion of needing to provision and configure infrastructure solutions, but really in the world of infrastructure as code, which is kind of a byproduct of, say, the DevOps revolution. So this desire to treat all of your infrastructure and in addition, third-party solutions that may make up and compose your stack, to control all of that as if it were software itself. So doing that through infrastructure as code principles and practices, and that's really where Terraform sits. It's all possible due to this concept of a provider network, which you can think of as like a plugin that would integrate or operate with particular software vendors or public cloud offerings. What Terraform will then offer you is a standardized tool and workflow that you can use across a broad ecosystem of technologies where most people find themselves operating these days, whether that's across multiple public clouds or in most cases in hybrid cloud environments where you still have on-premise private data center solutions such as the Cisco portfolio, as well as public clouds and then third-party solutions that you may bring and use in both locations. So I'm quickly going to review some Terraform concepts in our open source solution. And for those that are new to HashiCorp, all of our solutions first start as an open source project, and they're freely downloadable and usable in a number of environments. One common use case for Terraform tends to be as people start to pick up the tool and learn it, is to just run it on your laptop, for instance. So I'm going to walk real quick through the workflow of using Terraform as an open source user on your own laptop. So step one that you would do as a Terraform user is you'll go and download the Terraform solution, compiled to run on your favorite operating system. And Terraform is actually a command line utility. So that's going to be the first step, is just go ahead and grab whatever version you need for your operating system. The next step is going to be to actually write some Terraform configuration files. So there's a language we use called HCL, which stands for the HashiCorp Configuration Language. And there's a number of files that would be authored and stored in a working directory to use Terraform. There's plenty of documentation and examples out there, publicly facing, as well as on our own learn.hashicorp.com website as well. So lots of information on this concept. But step number two, you're either going to have to copy an example of some Terraform code or author your own. Once you've done that, you'll need to instruct Terraform to initialize itself. So there is this Terraform init command. When you do that, the Terraform command line utility is actually going to reach out, and it's going to discover any of these providers that it needs to execute the work that you've instructed it to do. So if you're going to be configuring some Intersight workloads, Terraform will need to download and make available the current version of the Intersight Terraform provider. Likewise, if you're going to be provisioning into AWS, same motion. Terraform will recognize that you're instructing it to use the Cisco or AWS provider, and it will go and attempt to download that from a public-facing location. And we also have support for privately hosting or making available non-public facing copies of providers as well. So that's going to be your step three, is to initialize Terraform. The fourth step is known as a Terraform plan. And all of these steps, by the way, when I'm getting into 3 and 4, these are actually command line commands. So literally Terraform init is one command. Terraform plan is another that you'll pass to the CLI utility here, the Terraform open source utility. When you do a plan, what it's going to do is perform a dry run. And in that dry run, it'll do a few things. It's going to verify the syntax of all of those Terraform configs that you authored and made available in its working directory. If there's any syntactual errors, it'll warn you, which is pretty cool, because then you've already got that first troubleshooting attempt. If you've configured anything incorrectly, you can go back and fix the code. The next thing it will do is it will talk to the endpoints. So the providers that you're instructing Terraform to use, it'll reach out to those APIs, and it will run through the scenarios that you've instructed it to do and report back the output of that. So if it was spinning up some virtual machines in Intersight, if it was deploying a IKS cluster in Intersight, if it's deploying EKS in AWS, that information is going to be reported back, and you're going to get this report. If this Terraform plan is executed, this is what it's going to do. So you have a chance first to glance at everything that you're about to do before you do it. So that's the dry run of Terraform plan. The next step would be what's known as Terraform apply. This is the point where Terraform is provisioning and or configuring resources in the target. So the assumption here is you've looked at the plan, you're okay with what's about to take place on the platform that you're choosing to operate on. And when you run the Terraform apply command, Terraform executes on your behalf. That could be deploying workloads in a private data center, configuring Cisco solutions, or deploying workloads into a public cloud. And sort of the last thing that happens in the open source workflow is the Terraform tool will create what's known as a state file. And this is a plain text JSON blob, and that will wind up in your working directory. And this is a record of everything that has taken place and what was reported back from that provider that you were using. So this would be outputs from Intersight. This would be outputs from AWS in my example. you'll gather all this information here in this state file. And this is now the source of truth for Terraform going forward. This is its view of the world, of the resources that it created for you. So it's important to understand these concepts because we're going to build on this as we talk about commercial offerings of Terraform and then move into the Intersight partnership and integration work. So in the open source use of Terraform, there's a couple of considerations that you need to be aware of, especially when operating in a enterprise setting or any kind of production workload support using the Terraform tool. So the first here is to do all of this Terraform magic against these providers and operating targets that are supported, you're going to have to provide access keys to the Terraform CLI tool. And in the open source use of Terraform, the way this typically happens is access keys are set as environment variables. So in the example of a laptop, setting environment variables on a laptop, or in most cases, hard-coded into a config file somewhere that's referenced. So both of these motions can kind of raise an eyebrow from a security standpoint of how you're managing privileged access and the secrets necessary to use the Terraform solution. I mentioned the state file that gets created after Terraform has provisioned or configured workloads for you. And in that human readable JSON blob, just plain text, there is sensitive data, and the state file does need to be protected. And in our open source solution, we don't actually support out of the box collaboration. There's some things that you need to take action on to make that state file available to another member of your team and things like that to work together on it. So definitely a few concerns around state and how it's treated when you use the Terraform open source solution. And the last point I want to make here on it is a command line utility. So to use Terraform, you will either have to manually execute those CLI commands yourself as in a human, or you'll need to script those or wrap them with another process that executes them for you. So this leads us to kind of a common practice now with Terraform open source is people find the tool, it really fits their needs and the challenges they're trying to solve with their infrastructure as code initiatives or building pipelines or operating in really this modern era of application development where we want infrastructure as code to live alongside our application code. So what will tend to happen with the open source tool is people will start to develop workarounds for some of the things that our free version of Terraform doesn't offer. So here's some examples I want to share would be, instead of using your laptop to run Terraform, maybe teams will dedicate a virtual machine or a container to run Terraform on and then limit access maybe just to the members of their team that are using Terraform. And then another kind of evolution would be, instead of having that working directory just living on your laptop or on this dedicated machine, would be to integrate with a version control system and start to store all of your Terraform configurations minus any sensitive data in a version control system so that you can work together at least on authoring Terraform code and sharing it with other members of your team. This access key problem is really all over the board of how people address this. It could be anything from continuing to set environment variables on that virtual machine, the hard-coded config file, but being very cautious not to check that into a version control system, maybe storing secrets in a public cloud key value store or security service, things like that. But really what it leads to is there's not necessarily a standard way of handling secrets in the open source use of the tool. So it will vary. And kind of the last step here is the state file. One solution that to managing state file and access to them would be to store them in, say, an object store and then control access to that versus just only having a copy on your laptop or on that dedicated machine. And this in and of itself can start to sprawl if you have multiple locations where state is being stored, and you definitely have to be aware of who has access to any object store where it is stored. All right, so where I'm going with this is really just want to make sure that people understand that Terraform open source is a very powerful tool. It can help practitioners learn how to use it very quickly because it's freely downloadable. There's tons of documentation and examples out there to help you ramp quickly on how to use this tool. But the note of caution here is using it in the workplace or bringing it into an enterprise or a regulated organization. There's some issues that need to be thought through. And mainly it's the fact that Terraform open source doesn't scale. So what I mean by that is if you kind of look across, say, the scenario of multiple teams in the same organization that have all decided to start to use Terraform, each one will have to create their own custom process for solving for some of these challenges that I just introduced with the open source that aren't necessarily solved for in the command line tool that's really downloadable. So if we look at development team X here in this example, maybe this team is just sort of, laptop jockeys just going for it, and everybody just runs Terraform on their laptop. They write Terraform code on their laptop, and just keep everything there. That, for one, is completely not safe for production workloads, and there's a lot of risks introduced with just using Terraform on your laptop where it's very vulnerable and brittle. Your laptop could be dropped, stolen, etc., and with it, configuration files, secrets, access keys to your public cloud subscription or to Cisco systems on-prem. So really, really not recommended for any sort of production use here to just run it on the laptop. Development team Y here is going towards we can solve this with our own process direction, right? And this team may have the dedicated virtual machine or container, only limited access to dev team Y, also storing state off in an object store and using version control system to store their configuration files. There's challenges with this though, in that only this team has access to use their instance of Terraform. Only this team has access to the state files of whatever they've created. And there's other issues too, that whatever decisions they make may not be standard decisions for the organization. If this team Y decides to use a version control system that's not the standard, if they're operating in a public cloud that's not even the standard cloud, there's a number of factors that can roll into them just creating their own way of using the tool. And this last scenario here would be development team Z. In this case, they're a little more advanced and in starting to use CI/CD tooling, and they've started to adopt a pattern where Terraform could actually live on, say, a CI/CD runner. So think of like a GitLab runner or something like that. And they've integrated it into their pipeline workflow. They're safely storing state in an object store, but there's still some problems with this as well. Again, if their CI/CD tool of choice or their GitOps workflow is sort of their own thing that hasn't been adopted widely in the organization, they're really the only team that's able to take advantage of this capability. And again, they may be violating some standard practices around secrets management in their organization. And there's the picture I'm painting here with all of this is there's a lot of decisions that can be made per team, and those really lead to custom processes. And what that nets out to in a production setting, in an enterprise setting, is that your security compliance teams do not like custom processes and homegrown solutions. It creates a lot of problems when an audit needs to take place or some assertion of best practices or security compliance is being followed. Not having access to any of these environments where Terraform is being used, not having direct access to state files, or even a knowledge of how Terraform is being used and where it's being used in the organization can create a lot of problems. And additionally, some key points around the open source solution is out of the box, freely downloadable. Terraform open source does not provide centralized visibility. There's no centralized operations. As you saw, it can be run sort of anywhere that a team chooses to and in their own way. There's no access controls built into the open source solution. It doesn't solve for secrets management out of the box. That's something you need to solve for. There's no compliance enforcement to say, these are the rules of the road when operating in a particular public cloud or private data center solution. And really the story here is, just be aware of this, right? It's something that needs to be thought through. And really that tipping point, I would say, is the moment you start to use Terraform open source in support of a production workload is really like the number one thing I consult people on. In development sandbox environments, move fast, be agile, but please put some consideration into the operational concerns of using this tool for any production workload that is critical to your organization. So that brings us now to some of the commercial offerings for Terraform. Some people actually aren't aware that HashiCorp has a commercial offering for Terraform because they're so familiar with our open source tool or solutions that are freely downloadable. So Terraform is available in a solution known as Terraform Cloud, and this is our SaaS-based solution. And at a high level, what this solution offers is really kind of building on those problem statements that I introduced. HashiCorp has introduced an opinionated solution to using Terraform at scale. And what that is this notion of some dedicated compute that's devoted just for Terraform operations, that's controlled just for that purpose. We have a secrets management solution at HashiCorp. It's our Vault solution. And we've integrated that solution into our Terraform Cloud solution. It's not something that, as a Terraform Cloud user, that you really need to know anything about or have to operate it independently. It's there providing encryption services and protecting any sensitive data. We also integrate the solution with a persistent database for any metadata and historical audit trail tracking of what Terraform does over its lifetime. And we also integrate with an object store to store your state files encrypted even before they get to that object store. There's some other concepts over here to the right of the diagram where instead of using a laptop or a dedicated virtual machine, since the platform has control over some compute resources, it can spin up what are known as runners. And in an ephemeral way, on demand, say, I'm going to run a Terraform job. I'll do it in an ephemeral compute runner in our SaaS platform, scrape the outputs of the apply or the plan or the state, and then destroy that runner once the job has been completed. We have integration with all of the popular version control systems, and we also have this concept in our commercial offering known as Sentinel, which is a policy as code enforcement engine. The other key point here is our Terraform Cloud solution has an API, which is huge because in just the open source use of our tool, you have to wrap it with scripts or build it into some kind of pipeline because it doesn't actually have an API in the CLI version. And of course, there's also support for the use of our commercial offering. Some other concepts real quick here that get introduced that don't necessarily exist in the open source is the API, of course, and then building on that, we've introduced in our platform a role-based access control hierarchy. We have support for users, groups. We can issue tokens and scope those to various degrees of granularity to achieve a principle of least privilege as you operate at scale. Some higher level concepts here too is we have this notion of an organization, which then includes the ability to host a module registry privately to just your organization. We have that Sentinel policy capability. And then really the kind of the unit of measure in our commercial offering is this concept of a workspace, which is a little different than open source workspaces for anybody who's been exposed to those before. These workspaces have a unique identifier, and then with them, we can attach a version control system repo to it. We can independently track the life cycle of a workspace from the moment it's created and everything that it's done throughout its life. And there's a number of other features that we can attach to that too, like secure variable storage. The ability to collaborate is huge here. State history. There's ways to even trigger events from the completion of one workspace to then trigger an event in another. So like chaining behavior, all sorts of things. And these are, again, not features that exist in our open source offering that, if you're looking to do this type of stuff, you're going to find yourself needing to create some type of capability to address these features that we have in the commercial offering. Kind of the last thing here, though, is at the bottom of my list called out against Workspace ONE. There is this concept of agents and agent pools, and we're going to get to that when we tie in the Intersight solution. So speaking of Intersight, recent announcement from Cisco that came out during their Cisco Live event is their Intersight solution, which is really kind of evolved over time to go from, a sort of phone home monitoring solution to now really this modular platform where they're starting to introduce other capabilities and solutions to make the private data center more cloud-like and to make it, API addressable in a scenario where you may be dealing with disparate solutions that don't, natively talk to one another. So Intersight is really kind of coming in as that API layer and kind of stitching together and gluing together some of the private data center elements necessary to function more cloud-like in private data center. So real quick on that, with the recent announcement, Intersight has kind of a core offering, which is set kind of in the middle of this rectangle, their Intersight Infrastructure Service. And above that, there is this module concept of being able to plug in different capabilities based on where you're at with your private data center automation journey. And in the upper right corner there, you'll see the Intersight service for HashiCorp Terraform. So that's the recent announcement. And this, we're going to dive into what it is in very specific detail. But the Intersight service for HashiCorp Terraform is really an extension of the Terraform Cloud solution. And we're now talking about Intersight, which is a SaaS solution, having this joint capability together with both SaaS solutions, Intersight and Terraform Cloud. So let's talk about that a little further. So quick history on Terraform Cloud. In it, I've mentioned, as I showed you the diagram of the platform, this concept of a cloud runner or an ephemeral runner. So if you picture Terraform Cloud, it's a SaaS offering. You can integrate probably one of the most common use cases or workflows that we see with Terraform Cloud is modern developers and modern infrastructure teams linking a version control system to the offering. And we have support for a wide range of different version control systems to do this. Once you've done it, you're actually introducing a couple of things. Your development workflow is actually a Git-based or version control-based workflow. So as a user of Terraform, you can author Terraform and then check it into a repo, go through any approval processes that you normally would in a version control workflow. And really that nets out to, does the team agree with what you've written? Has it gone through some type of validation test? And if so, it moves on in a branching strategy and eventually gets merged to like a master branch. When that happens, we have some webhooks that listen for that activity, which can then trigger action on Terraform Cloud's part. That action would be using a cloud runner associated to a workspace that says, hey, I have something to do. I'm monitoring this repo. Somebody checked in some fresh Terraform or made a change. I now know what to do with that. I'm going to go provision a workload or configure a workload that's already been provisioned due to a change in a public cloud, for instance, in this example. So this method makes a lot of sense for public cloud users because we're used to working with public cloud APIs just being exposed publicly. AWS exposes their API, all the major clouds, Microsoft, Google, and they have their own systems in place to protect those APIs from DDoS and other things like that. So everybody's kind of comfortable with that. That's just how public clouds work. You can hit their endpoints. So when you think about our Cloud Runner being hosted by HashiCorp, this makes sense to go, say, from HashiCorp's SaaS offering directly to a public cloud and execute some Terraform activity, and then you get all of this audit trail history and control. The next scenario I want to introduce here would be this concept of doing something like that in an on-premise data center or a private data center. So if we look at that use case, in this world, you don't normally expose your API endpoints for your infrastructure to just public-facing internet. And for our Cloud Runner that lives in Terraform Cloud's platform, that's outside of the private network. So for us to execute Terraform against an on-premise solution that has a provider, those API endpoints, say if it's a compute, storage, network, or security solution, would all need to be exposed publicly for Terraform to be able to navigate and find those endpoints. This use case, when we first introduced Terraform Cloud, really did not land well with our enterprise user base. As if you look at that ask, it's a pretty heavy ask to Swiss cheese your firewall and expose all of your core infrastructure API endpoints to their control planes. Not too many people were jumping on board to do that. So I have Kyle today. Kyle, when this happened and we saw this at the launch of Terraform Cloud, it kind of led to a new iteration of Terraform Cloud. You want to talk about that real quick?
Yeah, absolutely. So this kind of, as we go through the process and evolution of Terraform Cloud, it really got to the point of where a lot of these on-premises customers really wanted to have access to the latest and greatest features that Terraform Cloud could introduce. Those things that Vinny was talking about already, wrapping RBAC controls around their configurations, securely storing state files, and so on and so forth. But they couldn't use it because, again, they weren't going to introduce all these firewall rules that were going to, maybe change and maybe, be modified over time. Nobody wanted to go through that change control process. So what happened is we introduced a new tier amongst the Terraform commercial offerings called Business. And what the Business tier does for Terraform Cloud is it introduces a number of features that a lot of our enterprise customers have really come to want and desire. Some of those include the ability to have audit-based logging through our Audit Trails API service, allowing some of those other log aggregation systems to be able to pull those logs and know exactly what is happening when and have a really great history of what's going on. We also introduced single sign-on integration. So you can integrate your Azure AD, your Okta, your SAML v2-based authentication mechanisms into Terraform Cloud so that you can still maintain that level of permissions with the products and services that you're already using today. Then we also open up, we kind of, reevaluated the firewall rule issue. And so we've started posting public IP addresses where these services can be found. So if you still do find yourself needing to go down that path of pinholing your firewall in order to get access to these resources, that is available as well. However, the last big feature, which I believe Vinny's going to talk about next, is really what separates Terraform Cloud for those on-premises enterprises.
Absolutely. Thank you for that, Kyle. So building onto this illustration is representative of the first, or the Terraform Cloud initial offering that was launched. And this offering still exists if you don't have a private data center requirement. And what came after our first iteration of, on the wrong screen, what came after is our Terraform Cloud Business tier that Kyle just, high level mentioned some of those capabilities. The biggest a feature that directly corresponds to this problem statement that I introduced of exposing a bunch of API endpoints from your private data center to our SaaS offering was solved through a solution that we introduced called the Terraform Cloud Agent. So as you see here in the private data center space, lower right, we have this concept of being able to schedule a Terraform Cloud agent, and this is just Terraform Cloud without Cisco right now. To do this, you'll deploy this agent. It's a Docker container that would run on infrastructure of your choice. That could be some clustered virtual machines. That could be on a scheduler of your choice. But once these agents come online, we're really just an outbound poll over 443 to a handful of aliases that our SaaS listens on. And once we do that, we're now able to use this agent or runner locally behind the firewall with minimal penetration and polling back to an agent pool in our SaaS control plane. So any work that needs to be executed for a target that lives behind a customer's firewall, we now have an elegant solution to address that with the use of a cloud agent. And from there, the workflow really nets out to, if the solutions that live in your data center have a Terraform provider, we now have the ability to extend the use of those solutions to a modern development team and supported in an infrastructure as code-based workflow. So you know how to use Terraform against public clouds. You can use Terraform against private data center technologies as well. So long as there's a Terraform provider to support that, we now have a way to reach behind the firewall and still deliver all of the value of using our SaaS offering, but meeting our security and compliance teams in the middle here with an agreeable solution of how that can look from an implementation standpoint. So once we introduce this capability, we can now talk about what we're doing today with Cisco Intersight. So Cisco Intersight is also a SaaS solution, and there's a couple of workflows that we're now able to support when it comes to Intersight, and a combination of Terraform Cloud with what has been announced as our Intersight service for HashiCorp Terraform offering. So the first workflow I want to show you would be, since Intersight is a SaaS offering and it has an API and capabilities and reach into the private data center, we can treat Intersight as another public cloud target, similar to the way we would treat AWS or Azure or GCP. We're able to do that with the Intersight provider for Terraform. How that workflow could look is similar to talking to a public cloud. If you're going to be using Intersight capabilities that have been exposed from your public or from your private data center and integrated with the Intersight offering, you now have an API to tap into using the Intersight provider, and that cloud runner communication makes sense. Intersight is, a SaaS solution. They have some publicly exposed APIs they protect. So we can talk Cloud Runner to the Intersight API and provision and configure any solutions that are integrated with Intersight. So if you see here on the lower right, if I have, compute, storage, network security solutions that are within reach of Intersight and have been integrated, which is one of the values of Intersight. They work with third-party vendors and kind of stitch some of this together in the private data center. We can now control it the way we would another public cloud. But when we look at the next capability here, calling it SaaS to agent workflow, where the previous one was SaaS to SaaS. Here, Intersight actually has a concept similar to the cloud agent living on-prem behind the firewall, which is known as their assist appliance. Similar deployment concept, but what we're doing now with the integration is leveraging that assist appliance, which is placed behind the customer's firewall. That assist appliance subscribes to the Intersight SaaS, and that's the point of integration where Terraform Cloud agents can be scheduled and run on an assist appliance. So this kind of offloads the need to manage your own infrastructure behind the firewall or have multiple instances of cloud agents running for different teams and then kind of going through that request and approval process of getting the Cloud Agent access to all of the endpoints it's going to need. With the Intersight Assist Appliance, you can do that once and then start to introduce Cloud Agents and ride a lot of that, those security and networking decisions that were made up front. The agent's still going to behave the way it normally would. However, its outbound polling then just gets proxied between the Intersight SaaS solution over to Terraform Cloud, where it's able to subscribe to the agent pool and wait for something to do. And once we do this integration, it's the similar story, right? We now have the ability to use Terraform behind a firewall against any technology solution that has a Terraform provider. So this really then extends the reach of Intersight's API, as well as the need to further automate some type of workload or configuration that Intersight doesn't have full integration with. So it's really a complete story here of infrastructure as code coverage for hybrid cloud scenarios. We have all the public cloud capability. We can treat Intersight as a public cloud and operate SaaS to SaaS. And then when there's a need to configure and use Terraform against solutions behind a customer's firewall that have not been integrated into the Intersight infrastructure service, you're able to complete that story. So there's this broad reach that's now been introduced with the Intersight service. So for Cisco customers that are currently an Intersight customer or in looking at and investigating that solution to help automate their private data center, we have this complete story together with our solutions. All right, last point on this, and we want to get to the questions. You might look at something like this and say, who is this solution even for? So there's three personas that kind of come into this conversation. So on the far left, modern developers are really the infrastructure as code consumers of today. You know, they've already understand these concepts. They use them today in public clouds. And these are like your cloud native, automation driven, or agile development types of teams and people. These people are probably, in most cases, already using Terraform or aware of some type of infrastructure as code initiative. So what we're offering to the modern developer now is the ability to consume private data center resources using the workflow and technique that they're already accustomed to if they're a Terraform user in public cloud. The middle persona here would be, and the middle and right personas are your on-premise operations teams. So what I like to say is this area of concern exists in the private data center now. Public cloud consumers are abstracted from this persona. You know, AWS, Azure teams, Google teams, they all do the operations for the cloud service and offering. And you're not aware of any of the work they're doing, nor do you have to be. You just consume public clouds. In private data center, that's not the case. And we still have our on-premise operators and our on-premise operators of compute and networking domains. So when we start to talk about where does Terraform fit for these personas, in the middle persona of like compute producers, as I'm calling it, or maintainers, if you will, that maintain the service. Think of people like server admins or hypervisor admins or storage admins. These groups may not necessarily use Terraform to configure and maintain their server and storage devices, but they do need to be aware of people using Terraform to consume their service. So there's some integrations and some education that needs to take place in that audience here and in this persona to understand. To support infrastructure as code consumption, you need to be aware that Terraform is a thing, maybe participate in some of the best practices of how it's used against your service. And on the far right, our networking persona, there's actually a lot of focus in the networking space today in this movement of network infrastructure automation. So in most cases, your on-premise networking team may already be looking at advanced forms of automation. They could even be a Terraform user already. And other use cases for on-premise networking teams would be They tend to manage the hybrid cloud networking, so bridging the gap between private data center network fabrics to public cloud interconnects and things like that. And then also, I've included in there, if you're operating like a network operating center or a security operations center, having visibility into what Terraform is being used for can be just one more metric used to troubleshoot outages or understand security events and establish metrics on known regular behavior. So there are some integrations with our platform to send information over to networking and security monitoring solutions to see what are those infrastructure as code people doing, what is normal for a day in the life of them against our private data center environment, so that we know if we're being attacked or if it's just a sprint to get something released and that's normal behavior. So what I'm trying to paint here is really Terraform kind of spreads wide across all of the domains and traditional silos of technology that we've seen in the private data center. And there's intersection points where some people need to be informed while other people will directly use the solution. So it's kind of for everybody. Anybody who has an infrastructure as code initiative in a private cloud or hybrid cloud setting. All right, I've talked a lot. We have a little bit of time for questions, so let's jump into that.
Fantastic. All right, for those attendees, please feel free to drop some questions into the Q&A box, and we will address them as they come out. However, we already have a couple questions in, so let's dive in on those. So first and foremost, when it comes to infrastructure as code, Vinny, can you kind of walk us through the concepts of mutability, mutable infrastructure versus immutable infrastructure?
Yeah, absolutely, Kyle. It's a great question, and that comes up a lot. And yep, thank you. There is a little bit of feedback, Kyle, when you come off mute, but you got it. All right. Actually, this conversation comes up so much, I planned ahead, and a peer of mine, Andrew Horrigan from Cisco, he's actually on the PMM side of Intersight. Recently, during his talk at Cisco Live, we've kind of riffed on this idea of like mutability and if anybody's familiar with the term pets versus livestock, that we started to talk about the private data center in the context of maybe being more of the farm. So, but what we mean when we talk about like pets versus cattle is this concept of the behavior that happens, after day zero. So if you look here at this slide, and I'll try to do this, there's a little bit of a lag on the presentation, but I'm over here on the mutable side where we've got a dog and a cat, which represents pets. And in kind of the way we used to operate pre-public cloud and DevOps infrastructure as code would be at day zero, you would develop some software and then have infrastructure deployed, use whatever means, config management, whatever, to deploy that software onto the infrastructure that was stood up. Maybe it's a 3-tiered app or whatever. And maybe even no automation was used at all to deploy that application. People literally just by hand installed it and configured a complex application. And then from that point on, day 2 and beyond, configuration changes or any modifications to the application or the infrastructure really followed this cycle of requesting a change, maybe using a ticket, an ITIL approval board, and saying, I'm going to go change the tables of a SQL database. I'm going to go upgrade the operating system to the VMs that run this or whatever. And once that was approved, they would make the change on the infrastructure directly. That describes immutability. So mutable in the sense of mutating the infrastructure that has been deployed. So in-place changes to resources, the application itself on the living, breathing infrastructure that has been deployed. That's mutable or mutating infrastructure. On the right of this diagram here is this concept of immutable. And this concept is really similar, right? We develop some software, but when we're ready to deploy it, we'll take that next step of saying, we've developed and written some code. We need to write some infrastructure code. We don't want to point and click our way through deploying that infrastructure. We want it to all be expressed as code so it's highly repeatable and documented to where we know exactly how this was deployed day one. So insert Terraform. We have our application code. We have our Terraform to define the infrastructure. We now deploy it day one. And when day two rolls around and we need to make that change to the memory or the application itself, we go back and develop more an updated or a new version of our infrastructure as code configuration. So that change would now go through a version control system review to say, okay, you're trying to increase the memory or change the deployment in some way of this infrastructure. I can see it in the code. I can see how it used to be expressed. I see how it's expressed now. That gets approved. You then redeploy your infrastructure, and in most cases, you destroy what was deployed and redeploy with the changes. So that refers to immutability, meaning we don't want to mutate that infrastructure. We want to destroy it and then redeploy it to meet this new definition of how it should look and feel. And along the way, we now have the breadcrumb trail of every change that's ever taken place. We can roll it back or forward as needed, and it's highly repeatable. So that was kind of a long-winded answer, but hopefully that introduces the mutable versus immutable conversation, which is actually a very important concept and a lens to look through when we're talking about Terraform, because Terraform really sits in the immutable camp, and that's really where it shines. What other questions do we have, Kyle?
All right, one new question just came in, and it really addresses the migration strategy for those who might already be using Terraform in their own environments. So can you talk a little bit about the migration strategy that some of those users and practitioners might be able to either perform or plan for as they kind of take a look at moving into a Terraform Cloud and Intersight collaboration partnership?
Yeah. There's a few concepts at play there. Historically, people have always asked for a magic wand that Terraform can just discover, some resources that are deployed into a public cloud or configurations made on some solution that has a Terraform provider, and ingest those and create a state file, based off of, where you're at. And now you've kind of like P2V'd your infrastructure as code path. So for private data center folks, they should know what I'm talking about, because this is when virtualization hit what people did. I don't know how to rebuild this application. It's on a physical server stack, but I want some of the value of virtualizing it. So they would literally take a physical server and virtualize it and convert it to a VM stack that now could at least vMotion and do stuff like that. That concept, I'm trying to draw a connection to that because there's ways to import and discover, configurations that weren't originally done by Terraform. And there's ways to do it. They're not super elegant and easy. And we even have some partners that specialize in things like that. But it's sort of, it's not the correct approach is what I'm going to say, because if you think of that physical to virtual scenario, you've kind of kicked the can down the road by doing something like that. And you're sort of kicking the can down the road if you import, some state from an endpoint that Terraform didn't originally deploy into. So you're kind of reverse engineering it a little bit, and you may still never discover the full story of this is how to consistently redeploy and recreate this thing. So there's ways to do some of that, but really the best benefit of using infrastructure as code is to, do some reverse engineering discovery, but then truly go down the path of fully understanding the automation and writing some fresh Terraform and vetting out the best way to deploy that because then going forward, you now have that full history and control over that configuration, and it can give you all of the benefit that you want out of infrastructure as code. So to kind of recap that answer, there's some ways of doing that, but you really need to question, what are you trying to accomplish by doing that?
All right. And since we're starting to run out of time here, we'll do one last question because it's fairly quick. What about for those users who might not be Intersight users already, or might not have it fully deployed? What's that kind of situation look for those?
Yeah, that's a great question. So as we looked at the architectural, the Intersight, the IST service, is very right now focused on a deployment method. So our ability to use the Assist appliance to instantiate our cloud agents, there's more roadmap around further capabilities and integrations with this offering. But that was sort of the first, big hurdle we saw, because, some people didn't want to be in the business of managing yet another tool behind their firewall, yet another set of infrastructure to run these cloud agents from HashiCorp, et cetera. So the answer to this is you can coexist with starting potentially with Terraform Cloud, and that, deploying the cloud agent outside of a Assist appliance model. The big question is that enough for your project and your security and compliance teams to be comfortable with starting there or not? And that's something you'll vet out internally with your organization. But there is the ability then to marry the solutions at a later point. So if you're in a phase of discovering Intersight and maybe based on the value you're looking to get out of these solutions, it makes sense to immediately hard charge with Terraform first while then bringing Intersight in later. There's ways to do that, and that aren't necessarily disruptive to one another. So if I'm answering the question right, you can kind of do both in parallel, and you can also bring them together at any point. And there's not necessarily hard technical restrictions to prevent you from whatever path makes sense for your journey.
Well, right. Thank you so much, Vinny and Kyle. I think we've literally run out of time. Great presentation. I hope everybody enjoyed today's webinar and that everybody has a better understanding about Cisco Intersight Service for HashiCorp Terraform. Just want to point out to the resources that are available. We'll send them as well as the recording of this event. Again, it usually takes a couple of days or 3 days to set it up, but I will follow up with an email to all the participants with the recording and resources. Thanks again, everybody. Thank you to our speakers. Have a wonderful day. Goodbye, everybody.